Hello everybody, welcome back. So as I explained in the part 1 of the video, this is where we are at the point. So we see the behavior of our system, how does the theta changes according to different parameters that you can change in the MATLAB. So what we want to do right now is we want to create a model that I presented before in order to be able to simulate it in the virtual environment. In order to do so, I'm gonna use a SolidWorks. So as we can see here, I have already a ready model, which is just a disk with a sticking element. What's very important, and this is gonna make your life much easier when you are creating such model, do it in the top plane, which allows it later for much easier simulation. So here we have our model, and now very crucial part. We are going into the save as, and we will call it test. We want to save it as a VRML file. We click over here, but that's not the end, okay? Now we are going to options, and depending on, sometimes you can get an error, so depending on what does the error tell you, I use RML 97 in units of millimeters, but this is very important that you change it because it's not by default and it can cause you some errors later on. So we click OK, saved. So now we have saved our file. Let's just make sure everything is saved. Okay, it is. And in order to start our simulations, we are still here. Okay, so what you want to do right now is you want to find this block called VRSync, Virtual Reality Sync, and you want to open it. Double click on it, click Browse, find the file that you are looking for. It's going to be the test file for me, and we applied it, and we want to edit it. So we click Edit, and the software should turn on. If the software doesn't turn on for you, make sure to check YouTube videos. You have many YouTube videos explaining how to do it, or just Google it. It's very easy. So this is our disk over here, and first thing you want to do is to change the name. By double clicking, we will call it disk. This is very important because if you don't do it, you won't be able to simulate your model. Now we want to make sure our disk. Now we want to change the viewpoint, meaning to see our disk from the top, so it makes our life easier. So what you want to do is you want to grab a model and make it basically look good, so you can see what is happening. Then you can create a viewpoint, and basically this will be the viewpoint that well, let's call it the top view, and then allows it later for you to be able to see it much more easily. We can also add a background color. That's obviously not required. We can go to appearance. Let's go to texture, libraries, import from texture library, and I like to use the checker one, so I drag the checker one into the texture, and it allows me to see the model in such a way, which allows it for easier recognition of what's happening with the system. Very important thing right now is we go into very important thing is to understand what do we want to do. What we want to do is we want to analyze the rotation of our body, which is theta. So what we need to do, we need to go into the rotation tab under disk. So we go inside, and now we need to see which coordinate do we need to change in order to simulate our body. So let's first change Z to 0, unclick it, then go to Y, make it 1, and then change the rotation. So as we can see, Y coordinates, our disk is rotating around Y coordinate system. This is very important that you note it. Also, as you can see, the coordinate system is a little bit shifted, but that's not a problem. We can see that I would like it, with that increase in angle, I would like it to rotate in the clockwise direction, but it does it in the opposite one. We'll be able to fix it later on, it's not a problem. Just keep it in mind. Now we click cancel, we save our file, exit it. Again, we click VRSync. So this is our model, but as you can see, we click play, nothing is happening because it's not connected to our system. We go into simulation, block parameters. This is very, very important right now. You see, because you changed the name into disk, this is why you are able to modify this part of the simulation. We open the tab, and here is basically what we define, what we want to change and what do we want to do with our system. So what we want to do is we want to rotate our disk. We want to provide an input of change in the angle and to be able to see it. So we click rotation. Very important thing right now, depending on what you choose, you see in the brackets SFR rotation. So in the link that I'm going to provide to you, this is Virtual Reality Toolbox, a guide that I found in the internet. You can just type in the exact name. So here we go, and you are going to be able to find this file. So what we are dealing with, our VRML type is SF rotation. Here you have the description on it, which is very, very important. Basically what it tells you that in order to be able to visualize your model, the first three inputs has to be in the same order, X, Y, Z coordinate, and the fourth input has to be the rotation of the angle. This is very, very important. Please keep it in mind, because if you later on input it in a different configuration, it's gonna cause your system not to work properly. So let's remember about it. You can also check it for the other systems as well. So we are going back to our system. Sorry for that. And we are clicking rotation OK. Now you will see that our VRSync has been uploaded. And basically what we need to do is we need to use dmax block. So no, sorry, my bad, it's a max block. Right, I got it right in the first place, sorry for that. So what this block is doing, it's taking two inputs and it's creating a vector which it inputs into our virtual environment simulation. So as we remember, our disk rotates around y-axis, but it rotates in the opposite direction that we want, that then we want it to do. So it rotates in the around minus y. What we need to create right now is a constant input. We open it and we create a vector 0, -1, 0. 0 is a rotation in the x direction, -1 it's in the y direction, and 0 is in the z direction. We input it into the first slot of this block. If you do it in the opposite one, it's not gonna work, because as I mentioned before, the first three inputs are x, y, z, and that define the rotation coordinate system, and the last one, this one, defines the actual value of the rotation. So if we are going to go right now here and we click press, meaning start, as you could see, the disk rotated. What we can do in order to be able to see it much better, we can change the time. Let's do it this way, sample time, and let's play it. Okay, maybe that was a little bit too slow. We don't have that much time, so opa. As you could see, this is the behavior, and it's exactly the same behavior as on the graph. You can put those two next to each other. Let's actually make it slower. Like this, and you can see what is gonna happen. So the system is running, we are reaching to the 1 second, and now boom, we applied torque. However, the external spring has counteracted our torque and it pushed it back to the initial position. So this is basically how you can do the simulations. There are many more things you can do. You can input more bodies, you can change the system however you want, but these are the basics. It's my first video, as I mentioned before, so it wasn't very professional, but if you have any questions, feel free to ask me. I will be more than happy to answer.